Hello and welcome back, everybody. Today we are flying with this beautiful 757-200 sitting here in London Stansted, and we're going to fly over to Milan Malpensa airport. We're sitting here at gate 34 right, and I'm going to show you how you would set up a 757 from start of a flight all the way until we shut down the engines again after landing. So I fly this airplane in real life, so tag along and enjoy this video. So I have to say, this FlightFactor Boeing 757 looks really nice on the outside. It's not perfect, but I think the overall look of it is really decent, and we are equipped with the RB211 545 E4 engines, 535, sorry, E4 engines, and we got the winglets. And as you know, I talked in my previous video, with the winglets, you need some additional planning to reduce the speeds when you're coming into landing, since they make the airplane even more slippery. Even without the winglets, it is a kind of a difficult airplane to control the speed, especially when you get started on the 757. It needs some getting used to it. And there's some different door configuration with the 757. This one has the two over wing exits. Some air carriers prefer to have basically a door here, which would be a number 3 right, number 3 door, instead of the two over wing exits. So maybe the next time you see a 757, you spot whether they have over wing doors or the R3 door. And we're in the flight deck. When we get to the flight deck, this is what it usually looks like. We're on ground power, IRS is turned off, and now we can begin working with the aircraft. So when we get to the aircraft, we initially perform checklist to power up the airplane so we don't forget anything. So battery is already on, standby power is to auto, the lights should be off. Since we're on ground power, the battery is not discharging. It's very important to check. And some airplanes have two batteries, some airplanes have one battery. This one says in-up, I'm not sure why. Two batteries mean it has a APU battery and a normal one, which gives you up to 90 minutes of electricity in case of everything fails. With only one battery, it would be 30 minutes. Then we check that the hydraulic electric pumps are off, the engine pumps remain on. They only start to work when the engines are turning, so we don't have to worry about it yet. Landing lever down, alternate flap selector normal, and we are on ground power. We'll obviously check that we have all documents we need for the flight, and then we come to this page. Check the overall condition of the hydraulic quantity. Doesn't say refill. I think at 0.75 an RF symbol shows, indicating that a refill is required, and then you would have to talk to maintenance. APU is off, no hydraulic pressure since the system is shut down. The oxygen pressure we check. We have a table for it depending on how many people fly in the flight deck, since you could have some jump seaters, and then you have to check if the oxygen pressure number here is sufficient. But this 1700 is a decent number, so there's nothing real to worry about it. Then we come over here, oil quantity 16, that looks good. All indications here indicating what they should, and yeah, and one is turning due to wind. And that is it for the displays. We would then perform a oxygen pressure drop test. So we would hold, not this one, the test and release switch for like 10 seconds maximum to see if the oxygen pressure would drop. And if it drops more than 100 psi, which it doesn't, it means that maintenance has forgotten to open the oxygen valve after servicing it. Alright, that is checked. We can turn the IRSs to nav. We got 3 of them. Now you see the on DC light. This is gonna be illuminated for around 10 seconds. And it should switch to the align mode. Make sure the parking brake is set, and we need pressure in the accumulator. And it should be above the amber band, and the amber band is around 1500 psi. Looks like 1250 here. It should be above 1500, something like that. And then you know that you have sufficient pressure to hold the brakes. You would come back to this panel. And yeah, this looks a little bit different in real life. You have the PDU switch, which should be guarded closed, and you would check for the flight recorder switch, which is usually here. It should be in the normal mode, and the service interphone, which is also not really displayed. It should be off. This is only used for maintenance. And you check the gear pins. They are usually here in a box, and you make sure that they are all inside of that box. You go through the cockpit and check all the emergency equipment. We can talk about this in a future video if you like to. And that's it for the initial 2 checklists. The next thing to do would be to set up the FMC. So nav out of date. Yeah, this is an old database from 2017. In the real world, you would obviously have to make sure that this displays the exact dates, or the dates should be within the time frame of your current date. And there would be a second database. So maybe if your current database here is not valid anymore, there would be a second one, and this should usually be the valid one, and then you can just copy and paste it on top, and then you would have the most recent and active database, which is required and mandatory for every flight. We check 757-200, this looks good. The RB211 535 E4s, like I talked about it, and then the drag plus fuel flow factor, which is given by company on the flight plan. This depends on aircraft age and additional drag due to dents and buckles, etc. We're not going to worry about it today. And the FMC guides you through the whole process. So you see those prompts, position in it, we click it, and we're on the position in this initialization page. So we check the last position, November 51, 53, blah, 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 and a GPS position. They look the same. Copy the FMC position, paste it in here to set IRS position. And then we can come over to route. And we are here in Stansted. And we are going to Malpensa. And flight number, what you would do, that's ABC 123. If that would be your flight number, you would put it in here, and you would have a button over here to send a request, and then company operation would downlink you the whole flight plan, and you would not have to worry about all the waypoint entries. But this doesn't work here, so we have to do it all manually. So let's see. Since this is an old database, we might have some problems with the waypoints. Okay, it gives us two choices. One waypoint north 50, one north 03, which is close to the equator. And since we are in England, United Kingdom, we are definitely not close to the equator, so north 50 would be it. Then upper mic, this is an airway, 733, and airways go here on the left side. Okay. Yeah, he doesn't like that. This is just due to outdated database. Then upper Tango 423. And this can take a while to put in all the waypoints by yourself. Yeah, again, mismatch, so we just take a direct. And imagine doing this for a long flight like over the Atlantic, which the 7.5 is approved to do. It's some of the 7.5s are ETOPS certified, and you can fly over the Atlantic like United Airways does it. And doesn't have the best range, but you can go at least 8 hours. So yeah, it definitely is a nice airplane. It can take on more payload as the A321. It obviously burns way more fuel. And with the new Airbus A321 XLR, etc., they have way better range and endurance than the 757. But the 757 still remains a bigger airplane and is able to take more cargo, passengers, etc. Alright, then let's see what we got here for departure. So, departure, Stansted, I'm expecting runway 22, and yeah. The Detling 1 Romeo, that looks good for now. We press departure arrival into Malpensa. What they would usually give you is one of the approaches to 3-5, either right or left. We're just gonna plan on the right and the Zulu approach. And let me check. Alright. I have to check this with my chart that it all makes sense. I mean, we have a couple of minutes during the flight where we can further look into it, and what usually happens is that it's going to change anyways. So a late runway change in Malpensa is not uncommon. So I'm just going for the Aztec. And those points, let's see if they match up with the ILS. Yeah, not really. Nah, they're totally outdated to the charts that I have. So yeah, we're gonna worry about it later. Activate, execute. Obviously, you would make sure that the initial waypoints up to a certain point all makes sense, and then we can worry about the arrival later on. We take a look later. Okay, next thing you would do is go to legs page, route data, and this looks different in my aircraft, and you could enter all the winds and download the winds via ACARS again, which helps calculate the arrival fuel, basically the performance predictions. So accurate winds are quite important to get a good estimate of the arrival fuel, which during flight I'm going to talk about more using the progress page. So gross weight, we don't worry about it yet, and zero fuel weight, we don't know yet. 4.7 tons, it's not gonna be sufficient to reach Malpensa, so we have to refuel, and zero fuel weight, gross weight. We get those numbers later on when we get the load sheet, the final load sheet. And I'm checking the flight plan here. So our reserves 3.3 tons, and we are cruising at 390. And just taking cost index 15. This number is given by your company. The higher the number, the faster you go, the more fuel you burn, and the lower, the more fuel you save, basically. Yeah, already got the message insufficient fuel. We acknowledge it. We still have to get the fuel in, and we go to the takeoff page. We'll leave all that blank. We're gonna worry about it later. Then acceleration height, we accelerate at 3,000 feet today. This is also company airport specific according to noise abatement procedures, etc. So today we will accelerate at 3,000 feet. At 1,000 feet we hit the climb thrust, and at 3,000 feet the airplane will pitch down so we can retract our flaps. Then you would check the distance, which is 587 miles. And my flight plan indicates 611 nautical miles. So this is within acceptable range. Yeah, for the fuel prediction, it already tells us minus 0.7, so minus 700 kilos upon arrival. Yeah, we cannot take off like that. What I would do is go here to the fix page and enter a 25 nautical mile circle for MSA reference. And the next thing is to enter a engine failure procedure for Stansted. So check with my performance app. And for runway 22, the procedure will be climbing straight ahead to ISX. And we need the runway heading, which would be 222, and then 5 miles. Let's see if he will take that. Yeah, so this point is my own creation, basically runway track of 222 up till 5 miles. And after 5 miles, what my performance app tells me to is to fly a right turn to Laurel. All right, there we go. And we would hold at Laurel. So Laurel, paste it in here. And we got 187. And we're doing left turns. This is very important. So now we have the holding set in route 2 in case we have an engine failure. We're gonna brief this later, but for now this is set up. So I go back to route 1, which is the active. I'm not sure why it says modified route 1. Gonna execute it here. Yeah, okay. Alright. Gonna leave this leave this page open on the takeoff reference. Or what we would do is under performance to give us a reminder, hey, we still need the numbers. Okay. So the FMC is all set. Then we would start on top and we're flowing down from basically row after row from top to bottom, top, bottom. So the IRSs, they are already aligned. If you turn this to heading and they are not aligned yet, you get a number in here. And if the number reads 5, it tells you 5 minutes to go. No lights here. Yaw dampers, they should work as soon as the IRSs are powered. So the in-up lights should be off. And we got system pressure, since we don't have any pressure in the hydraulic pumps. Obviously these would be normal, they're covered. We don't ever touch them unless it's something out of the ordinary. We check the lights, all those lights, they should be working. They're always on. They're for the pitot tubes, for the FO, auxiliary, etc. And they are illuminated because the engines are off, and they only start working when the engines are running, or at least if one engine is running. These are the door lights. Doors are closed for the time. We're gonna worry about loading in a second here. You can leave the HF to upper sideband. It's not gonna be used tonight or today. This is more concerning for long haul operation, especially over Africa or over the Atlantic. Made sure APU is on, no lights on auto. APU generator, we can put this to on. Ground power is on. It should also read available. You got 2 lights. And the bus tie is in auto. Make sure that these lights are out. Utility bus is on, so the galley has power. And you see a fail light and drive lights here, since the engines are not running. Some airports have APU restrictions, like 5 minutes before off-block time is like the earliest you can start it. Let's assume here are no restrictions. What you would do, you would turn it to start, and it is spring-loaded back to the on position. Just hold it briefly to start, put it back to on. It will conduct a self-test. And you see the fault, it's a self-test, it should extinguish. And when the APU is running, you get a white run light. That's when you know you can power the APU. In this aircraft, you would have to disconnect the ground power manually to switch the APU to power the electricity. And like I said, this would be spring-loaded to the on position, so this is not correct. This does also not work. The cockpit voice recorder, you would test it, get the green light. You can adjust your lighting for glare shield, etc. Since it's daylight, I'm not worried about that. Runway turnoffs, you can leave that off. And this is the light override. So when you push this, basically it overrides all the lights. Arm the emergency exit lights. This should be off. Ram air turbine, don't touch it. The engine limiters on. Every flight we toggle between this, and when this is indicating 2, we would go here to auto 2. Engine start selectors auto. Fuel pumps, they're all off. This one does not show a pressure light. That is because the forward left pump is feeding the APU. We check the fuel quantities. 0 into center, 2.3, 2.4, so it's almost, we can call it balanced. Total of 4.7, 14 degrees. It all looks fine. Anti-ice off. Wiper, we don't need it. Put position lights or nav lights on so we can check them during our walk around. Window heat on. This remains in upper sideband. And we are still fueling or going to fuel, so no smoking to on. Seatbelts off. Every time you have you are fueling, you have passengers on board, you have to leave the doors open, put the seatbelt sign to off in case you have to evacuate. And then we would have to set our field elevation for Malpensa. And this should be around 700, but I'm checking, yes, 690. All right, 690. And to auto, they should read 0. The equipment cooling, we don't use it for now. The lights off. And then you can adjust the temperature, cold, warm, depending on the outside temperature, of course. Trimmer, you leave it on. The recirc fans, you will leave them on. And the left one, usually you don't want to touch it because it can only be resetted on the ground by maintenance. Packs off for the time being. Isolation valve, we need that basically closed or open, so the flow bar showing, because the APU would only pressure the left side, as you see this flow diagram. So if this flow diagram is not shown, there would be no air transferred to the right side. So you couldn't start the right engine if this switch is off like this. You see it here. This is the right pressure gauge for the right duct pressure, and it drops to 0 since we now closed it. If we open the valve, boom, you have pressure. And you really have to check this pressure gauge here before starting the engines, because if it would read 0 now with the APU running, you would have a problem during engine start. APU is running, here's the run light. So now we can disconnect it. And now the APU is powering all the electricity. And we move from here up there, and then we come down here and we flow down over all those panels to check that everything is set. We already tested our oxygen. It should be set to 100%. Adjust your lights. We can adjust this later. Flight directors on, auto throttle on, and the FO would turn his flight director on, but I will do it as of now. This should be in auto, and we worry about the setup later. All switches are normal. It says no auto land, so something is not set up correctly for a auto land. This could be a radio altimeter, etc. But we will monitor this, and it should extinguish later on. If not, we know that we cannot perform a auto land. So we hit the preset, which doesn't work, and then we check one. So land tree, no land, land tree and no land tree, and we get the land 2 or no auto land. And yeah, I'm gonna change that to hectopascal since we're in Europe. This is auto, our brakes RTO, check the lights, engine system pressure, they extinguish at 18 psi during engine start. Reserve brakes, we don't worry about it, and brake source since we don't have the hydraulic pumps working yet. So we check through all the ICAS messages and we can cancel them. It says page 1 of 2, parking brake, engine shutdown, left pack off, right pack off, yaw damper, etc. This all looks good. And you clear it, because if something new pops up, you would immediately recognize this. Should be to auto. And we go to hectopascals. And yeah, make sure that the radio here is set, radio minimum set to 0, otherwise you get weird callouts during your standard ILS approach. And we will later set our engine out acceleration height here. You can put the flight path vector on your primary flight display. This gives you a good reference. Meters, we don't need it. We fly in feet. Adjust your range. And You can toggle here between VOR and the NDBs. And yeah, what I like to have is the airport, and this should read weather, no data. So later we will turn on the weather radar here, but we will leave it off for now since we do not want to harm any ground personnel. Okay, coming down here, the trim after landing usually is set to 4, it's at 4.5. Parking brake is set, they're all normal. Speed brakes retracted, cutoff, flaps up. Come to the weather radar, I'm gonna tilt it to like 5 degrees. It should be on weather and turbulence, left side, auto gain. We can set up the frequencies, but not to worry about that today. And we want to listen to the number 1. This should be in boom. This was in oxygen, so if you would put the masks on, you would need to flip this to oxy to talk to your colleague. But since we don't plan on using the mask, we take it to boom. Take this to both so we can hear both the range and identifier. No lights should be here, they should be down. And the transponder is on standby, ILS in park. And this should read 0. Same for here, no lights. And the FO would set up his panel. And that would be the flow to set up the cockpit initially. And I planned on using 132 passengers, cargo weight of 2450, and our flight plan indicated we need 9.7 tons of fuel. I just rounded it up to 10 tons, and then we can load the aircraft. Or unload it first. This is a little bit annoying in this version. You always have to wait until the airplane is unloaded and then load again. Instead of like in Microsoft Flight Simulator 2020, you can just adjust the weights immediately and it would change. So yeah, I'm not a big fan of this. Let's call maintenance. And let's wait until it is unloaded. In the meantime, we can set up for our departure. So departure frequency is 18825. We put this on the standby here. We have 1215, which is the guard frequency. We would have it active on the 2 and we would listen to it. I turn the volume down so you can distinguish if you are which channel you are hearing. So number 1 is or the left side is loud. Since this is the active talking channel, on guard you just monitor. And for ground frequencies, delivery is 21955, and then ground 217. And that is the usual setup for the frequencies. And now we can set up the MCP. So initial heading 222. Initial climb. We have a restriction to be maximum 5,000 feet. So 5,000 feet I will set up here. Speeds to come. And we want to set, in this case for the engine failure, the ISX, which is a ILS, so 110 or 110.5. Final course as well, 222. And you can park this frequency again if you wanted to, and then you would have it available immediately. Other than that, there are not too many usable VORs for this departures. There's Stetling, which we could set, so I'll press manual. and then put in the frequency, which is 17.3, and yeah, with the radial of 333. So yeah, and hit it back to auto, and I can flip the VOR left on. Alright. That would be the initial setup. Still waiting until the annoying loading is completed. Yeah, this takes a while. This is really annoying. I don't like that. And we're loading the airplane. It's gonna take a couple of minutes. You see the fuel is increasing. We want it to read 10 tons in total, so 5 each side. Center remains empty. That is the usable fuel usage. You would leave the center tanks empty, and you would only fill the center tanks when both of the wing tanks are full. And there are some slight differences between 7.5 models, but the regular would be 6.5, 6.7 tons per side. And the center tank holds significantly more, like 21.4, also depending on configuration. So it can hold up to like 34,000 kilos of fuel. And if we check the climb page, the normal climb profile in the 7.5 is 290 / Mach 7.8, and yeah, it should read 0.78. This is not simulated correctly. Yeah, I'm not sure why it says 0.739. This makes no sense at all. Cruise speed, I will not worry about it. This is depending on the cost index, but you can manipulate this. We can later check during the flight, like if you're delayed out of Stansted here, you could increase this speed to try to reach your arrival airport at the time you wanted to arrive there. Yeah, 290.739 or whatever. Transition level, we checked that. 6,000 feet here for Stansted. Finally done with loading. We got 10 tons as we wanted, 5.1, 4.9. Yeah, that is within limits. Maximum imbalance would be 884 kilos. So yeah, if we had an imbalance of 600, 700, I would slowly start to get nervous, and then you would have to perform a crossfeed and balance the fuel out. This you would usually do according to checklist, so you don't make any mistakes. And you closely have to monitor it, so you don't overfill the other side, which can happen if you forget about it. Okay, so let's close all the doors. They're indicated here in white. My airplane, they're indicated in amber. So close all. ICAS message disappears and the door lights go off. Okay, so we don't need that anymore. They can remove the chocks and bring the pushback truck. And yeah, ground power we can disconnect. We would signal this to the ground guys, and we would have received our final load sheet at this point. So we would go to performance, and I'm just taking advantage of the Xplane or sim version here, so you can just basically click it and it will give you the weights. 74.4. This is the zero fuel weight. Basically it's the weight of the airplane plus the passengers and the cargo. You would add the 10 tons of fuel, and this is our gross weight today, 84.4. And taxi to runway 22 isn't that long, so I would calculate with around 300 kilos, so our takeoff weight would be 84.1, and that is how we would calculate with our performance app. So we take 84.1 and we put in all the weather we got from the ATIS, and let's see, so it says CG22. I have to enter this on my performance app, and then it would give me the results. Then we go to the takeoff page, and this airplane is really overpowered and you want to save engine life, so we go climb 2, so it says TO2, so we have derated the climb power by 20% and it will still climb, really amazing. And flaps 5 for departure, CG is 22. This gives me the trim 4.2. My performance app says 4.25. This is within limits. We have a selected temperature of 59 degrees. So 59 degrees DTO2. And this is our EPR engine pressure rating 1.5. Well, it should read 1.54. This would not be acceptable in the real airplane. It could be 1.55, 1.53 maximum. That would be the range of tolerance. And you could select reference speeds to on, and it would automatically populate the speeds for you, but I'm taking the speeds from my performance app. So 136 for V1, 139 rotate, and 142 for V2. This is automatically set here. 142 for V2, arm the LNAV, and then we check the approach speed, 127, and 127 is what my performance app says, and we have to manually set the speeds in the 7.5. So speeds are 36, 39, 42, and 27. So 127. So the reference flaps 30 speed is basically our basic speed, and from this speed we can calculate all other flap setting. So the clean speed would be flaps 30 speed 127 plus 80 knots, so 207 knots. So if we have a speed restriction of 200 knots, I would know that we would have to climb out with flaps 1 because we cannot be clean, since our clean speed is 207, so it is above the required maximum speed of 200 knots, and we cannot fly without flaps at this speed. Alright, the performance is set. This reads pre-flight complete. Pilot monitoring would switch to legs page, and I would keep this page as pilot flying. And what we would usually have done is perform the briefing for departure, but I'm going to skip that since I will talk you through the whole process, how we're doing things. And as soon as the pushback truck is connected and they have the pin inserted, they will call us and tell us that we are clear to pressurize our hydraulics. And then we would go ahead. We start with the right electric pump, and we go to 1, 2, left side. Fuel pumps on for all the tanks where fuel is in. Center tank is empty. We'll leave it off. Anti-collision light on. Packs off. We check the pressure. Pressure is good for starting. We would go to the engine display, and 4.2 is our trim, so we set the trim 4.2 and put the transponder to XPDR. It's not an option here, I'm just gonna put it like this, and then we would read the next checklist. And after the checklist is complete, We would get clearance from delivery to get our pushback and startup. And then we would communicate with the ground tug, and they would let us know when they are ready that we can start our engines. Let's have a try at this pushback. I have been having some problems with this lately. So start pushback.
Ground to cockpit. Tow is driving up.
Okay, the tow is connecting, driving up. There we go. And before starting the engines, we would perform a recall. We got the parking brake, left, right engine shutdown, left pack off, right pack off, center hydraulic electric 2 pumps. This one is load shed, so this is totally normal. Both pilots would confirm this. We would cancel it again. And then we wait for the command of the pushback driver. Sometimes you can start them already here before pushback. Most of the time.
Okay, all doors and hatches are closed, ready to connect.
Most of the times during pushback you start one, and second one usually started after parking brake is set again, since it takes a while to start those engines. They start much quicker here in the flight sim than in real life. In real life, if you would flip the start switch to ground, it takes approximately 45 to 50 seconds for the engine to spool up. And to really stabilize, it's gonna take probably another 20 seconds more, at least. Okay, he's taking forever. And he's lifting us up. You can see that here. It's moving up. So he's pushing or lifting the whole front of the airplane up so that our nose wheel is basically in the air.
Release parking brake.
So parking brake release, and he confirmed again that the bypass pin is inserted.
Starting pushback, and you may start engines.
Okay, he cleared us to start, so I would tell him again, we're starting 2 and 1 in sequence and starting engine number 2, and then I would communicate to the FO, start right engine. So starting right engine, flip this to ground, wait for the light. The FO would start the timer as soon as the valve light extinguishes. We got a 2-minute limit on the starter. And then, yeah, this should not happen. And we monitor the N3, N2, so 25, 10, usually 5, or max motoring. I'm going to talk about that later. We can put the fuel in. Check the EGT, it should rise within 20 seconds. If not, you should abort the start. And the oil pressure is rising. Oil pressure light is out. And as soon as this red bar disappears, we have a stable engine. The red bar would be higher. Okay, we have one good start on engine number 2. Starting engine number 1. And same communication as before. Start left engine. Wait for the light. Set the timer again. Oil pressure is rising, so at 18 psi, it's not doing it, but usually at 18 to 20 psi, the low pressure light will extinguish. So 25:10, put the fuel in. EGT is rising really rapidly, wouldn't go that fast.
Operation complete. Set parking brake.
And we set the brake. Parking brake set.
Disconnecting tow. Stand by.
Waiting for this to disappear. It's gone. We have 2 good starts. This should be out. Okay, there we go. Can turn the APU off. Packs on. Isolation valve off. We open the secondary page. And then we wait until we see the pin from the marshaller. And then we can do flight control checks and put our flaps to our calculated takeoff setting.